In industrial safety, managers rarely face simple problems. The reality is a constant negotiation between what is physically feasible to correct and what is economically feasible to implement. To understand how to navigate these trade-offs, you will need to keep up with the weekly readings in our primary text, Industrial Safety and Health Management. You must document this process carefully. All of your notes, calculations, and practice work must be kept in a single, dedicated notebook. Keep it with you during every lecture. The parameters of this course are strict. The doors close 10 minutes after the lecture starts. Faking attendance for a friend will result in severe consequences for both of you, and no makeup exams or delayed assignments will be accepted. Just as non-negotiable safety regulations exist to prevent workplace disasters, adhering to these administrative parameters and completing the work on time is your only guaranteed path to passing this course. When designing safety protocols, managers don't guess. They rely on standard organizations like ANSI, NFPA, ASME, and NIOSH to supply heavily researched data and hazard control guidelines. We apply these guidelines to specific physical engineering challenges. Take industrial exhaust ventilation systems, where a major problem is managing the massive energy losses created when heating or cooling replacement air. We have three primary engineered solutions here: designing a closed-loop system to filter and recycle the contaminated air, introducing makeup air directly adjacent to the contaminant origin point so it immediately vents, or passing supply air through a heat exchanger to capture thermal transfer. Engineering controls like these handle physical hazard prevention. But to know if our safety protocols are actually working, we have to measure the reactive data from the floor. This formula calculates OSHA incidence rates. It takes the number of incidents, multiplies by a constant of 200,000, and divides by total employee hours worked. That 200,000 represents 100 employees working 40 hours a week for 50 weeks. For a scenario with 50 employees working 2,000 hours annually, our denominator updates to 100,000. To calculate injury incidence for 4 injuries, we explicitly exclude the fatality. 3 injuries times 200,000 divided by 100,000 equals a rate of 6. For illness incidents, 5 reported illnesses times 200,000 divided by 100,000 gives a rate of 10. The number of lost workdays rate adds 67 standard lost days to 16 restricted workdays. That combined 83 times our constant divided by the denominator yields 166. Calculate the lost workday injuries, or LWDI, for 1 qualifying injury, leaving out the fatality and injuries with 0 lost workdays. The final calculation is exactly 2. OSHA enforces these strict parameters so minor injuries don't skew severe impact metrics. We track these rates and enforce these design standards to prevent catastrophic system failures. For your mandatory notebook assignment, you will examine what happens when these safeguards break down. First, write a 1 to 2 paragraph breakdown detailing exactly what occurred during both the Exxon Valdez and the Piper Alpha disasters, and identify the specific steps needed to prevent those events from happening again. Next, conduct a comparative analysis. Look up the factors that led to the China port explosion and compare them directly against the mechanics of the Beirut port explosion. Round out the assignment by summarizing fault tree analysis and failure mode and effects analysis, including 5 to 6 sample case studies for each. And finally, research the top 3 industries for fatalities over the last 3 years. These incident formulas and post-disaster reports are real-world tools designed to save lives on the floor. Keep your calculations organized in your single notebook. Check the webpage frequently for updates, and submit all work directly to your designated group page.